I'm Dr. P.T. Kasturibai, Head Department of Computer Science. I'm handling a paper on Internet of Things for first MSc Computer Science students. Today we are going to see what is in IoT and what is the evolution of IoT, the characteristics of IoT, what are the layers in an IoT and the applications of IoT and the microcontroller unit. Okay. First of all, let us discuss about the evolution of IoT. In the year 1969, American Research Project Agency Network, it has introduced the concept of networking. And in the year 1999, the term IoT was coined by Kevin Haskell, who was working in Procter & Gamble Limited. In the year 2010, the smart devices and the concept of and the conversion of IPv4 to IPv6 boost IoT adoption began to emerge. Now billions and billions of connected devices, edge computing, AI technology and IoT are flourishing. So this is the brief introduction about the IoT. Now what is IoT? IoT is nothing but the interconnection of the devices such that they can collect and transmit or transfer the data among the devices via the internetwork. Say for example, home appliances, smart homes, smart cities, smart agriculture, all these categories come under the concept of IoT. Now what are the characteristics of IoT? We have the connectivity layer, sensing, intelligence, they are dynamic and self-adapting, energy aware, energy efficient and security and privacy aware. Next we are going to see the architecture of the IoT. There are four major layers in the IoT. One is a perception layer, second one is the network layer, third one is the middleware layer and the fourth one is the application layer. So in the perception layer, sensors and actuators are placed in the first layer. Actually they sense the information and pass it on to the cloud. The network layer. The network layer transmits the data to the cloud or to the nearest edge devices. From there it is transmitted to the cloud layer where the processing and analysis is done and the output is displayed as displayed in a dashboard or in a mobile app or etc. This is the final layer of the IoT. Now what are the hardware used in the each and every layer? Hardware, the first layer, like in the perceptron layer, as I said, we are using the sensors. So in this layer, sensors, actuators and microcontrollers are used. For example, of Arduino, ESP32, ESP8246, 8266 are the examples for the hardware devices. Communication, the Wi-Fi, BLE, Bluetooth, low range or Zigbee technologies are used for communication. The protocols used are HTTP, Constraint Application Protocol, MQTT, that is Message Queuing Telemetric Transport Protocol are used, and in the cloud platform we can go for an AWS IoT, Google Cloud IoT, Azure IoT Hub. The processing is done in the final layer, like you can do the analysis and get the output and it can be displayed on the dashboards. Next, how to develop an IoT application. Problem, you have to identify what the problem is and how are you going to achieve it. By selecting the hardware and the sensors that are suitable for the particular problem. Then the communication protocol to establish the communication and what is the backend you are going to use, the database and the data analytics tools and the UI what you are going to use. Say for example, Arduino IDE, Node-RED, Blink, ThingsBoard are the various tools used for this. Now applications of IoT. As I told you, the wide variety of applications of IoT we are going to see. Here smart home, healthcare, agriculture and retail, smart cities, retail. So this diagram represents the applications of IoT. First of all, we will see how it is applicable in a smart home. Say for example, I would like to control the air conditioner or I would like to control the refrigerator of my home from a remote area. So that is possible by using IoT devices. Sensors are placed such that when you have to switch on or switch off the air conditioner or depending upon the room temperature, how to control the room temperature. That can be done by embedding the software in the mobile, and so that you can operate or control the home appliances. That is your first application, which is the smart homes. Similarly, security. You can have a security to the house doors by providing smart locks. You can open or close the doors. Then energy management. Energy management in the sense, like you can, as I told you, the energy, the consumption of electrical energy can be preserved by switching on or off or reducing the temperature remotely. Second category is wearable technology. Say for example, wearable smartwatches, in order to sense our body glucose level or a BP level, and this sensed information can be displayed through a mobile app, or it can be sent to the doctors to whom we are consulting. From there, the doctor can suggest whether we need to go for a medication or whatever it is. Then, in that case, we can, it is used as an IoT device is used in healthcare as well as in a remote patient monitoring. Then, agriculture. Say in case of agriculture, precision farming can be done. Say for example, I would like to cultivate paddy crops in the land. Whether my particular farming area is suitable for cultivating paddy or wheat or maize or whatever it is. So the sensors like humidity sensor, soil nutrient sensor, temperature sensor, all these sensors can be placed in the land so that it can observe the soil quality, and depending upon the quality, I can cultivate what type of seed or what type of crop I would like to cultivate. So that plays its major role in agriculture. Similarly, when the crop is infected by insects, it can be sensed by a sensor, and using drones we can spray the pesticides onto the crops. So this also plays a vital role in the agriculture. Next, smart cities. Say, for example, smart parking can be done. It helps the driver to find the parking spaces. Traffic management. So, how whether you can choose that particular route to travel, or if it is over traffic flow is heavy, then you can reduce. Not to reduce the congestion, you can choose some other path. Then environmental monitoring. Like you can sensors can be used to sense the air pollution, so that the water quality sensing devices can also be used to sense the water quality, noise levels of the environmental factors. Waste management, like the transport vehicle can be sent to collect the waste from the dustbins once when it is overflowing. So sensor can be placed such that once when the dustbin overflows, it can be notified by the particular authority so that they can send the vehicle to collect the garbages. Other applications, connected cars to provide the navigation, entertainment and safety features. Transportations, like in transportation, vehicle can also be monitored and to optimize the routes and track the shipments. Supposing I am shipping a goods, RFID, using RFID, I can sense whether my shipment is going on a proper route. Then supply chain management, in order to track the goods, manage the inventory and optimize the logistics. So this diagram tells about states the applications of IoT. Next we are going to see the security in IoT. What are the challenges we are facing? The device vulnerabilities, data interception and weak authentication. This can be avoided by providing end-to-end encryption so that no intruder can enter into the system. Device authentication can also be provided. Regular firmware updates and securing the boot. All these are the solutions in order to protect the IoT devices. Then we are going to see about what is microcontroller. Small computers on a single integrated circuit, we say it as a microcontroller. Actually, the sensors will get connected to a microcontroller which can transmit the data from the sensed devices. It includes a CPU, RAM, ROM and IO ports. It is used in embedded systems for control applications. STM32 are the devices. Then next we'll see multi-purpose computer. General purpose computing devices. It can run a variety of applications and programs used in development and simulations of IoT systems. Then we are going to see about the electrical signals. There are two major categories of signals: analog signal, digital signal. Analog signals are nothing but which are in a waveform, like a sine wave or cosine wave. They are they are very prone to noise and distortion. Digital signals will have zeros and ones. Only 0 and 1 can be represented in digital signals. They are not they are less susceptible to noise and distortion. So, we always, computer systems mainly use the digital signal. So, we need a ADC, analog to digital converter, to convert these analog signals like temperature, moisture, all those sensed information must be converted into digital form so that it can be processed by the computer. Signals are mainly used for communication and control of the electronic systems. Now ADC, as I told you, it converts analog to digital. Similarly, DAC converts the digital signals into analog signals. They are essential for interfacing the sensors and actuators with the microcontrollers. So you need this ADC or DAC as an interface between these two devices. Then how to install and set up the Arduino IDE. So you can download from official website www.arduino.cc/software. There are different installation steps provided for different OS. Then connect the Arduino board to the system and then select the appropriate board and port in the IDE. Now the basic syntax of Arduino in C language is given. There are two sample functions taken: setup and loop. Void setup, serial.begin 9600. That is the data baud rate at which the data transmission occurs, the number of bits per second. Then void loop is for repeating this serial.println hello world with a delay of 1000 milliseconds. Now as usual, like C language, it uses the data types integer, character, float, boolean, etc. And the variables can be declared and the scope can also be given. Constant can be declared by using a constant keyword. Here these two are the example for variable initialization and a constant initialization. Then as usual, the C arithmetic operators, relational operators, logical assignment operators are used in coding. Now the control structures make conditional statement. If the sensor value is greater than 500, digital write LED pin, that particular pin port number, then display it as high. Else digital write LED pin, the particular pin number, display it as low. For while as it is, we can use like how we use in a C language. For I is equal to 0, I less than 10, I plus plus. Serial.println display the value of I. Then other library functions, serial.print, serial.println, delay, milliseconds, etc. is shown. Then for string, you can do the concatenation, you can find the length of the string, you can find the substring. All these are as usual like C functions. Similarly, mathematical functions, you can find the absolute value, power value, square root or a random value. The next we see what is Node MCU, Node Microcontroller Unit. It is an open source firmware and development board built around the ESP8266. It includes USB to serial converter for easy programming. It's a breadboard friendly layout. Onboard voltage regulator, it works with the 5 volts USB. So ESP8266 is a low-cost Wi-Fi enabled microcontroller board widely used in IoT projects. It has been developed by Espressif Systems. It is represented by Espressif Systems. It includes 32-bit Tensila, built-in Wi-Fi, GPIO, ADC, I2C, SPI and UART, Universal Asynchronous Receiver Transmitter Interfaces. This is a diagram shown, a sample diagram of a picture of ESP8266. Now it has the key features, microcontroller, and it has a 4 GB of flash memory and a 64 kilobytes of instruction in RAM, 96 KB of data RAM, Wi-Fi IEEE 802.11, I/O pins, 11 GPIO pins, communication port can be UART, SPI, I2C or pulse width modulation, PWM. The programming language can be Lua, Arduino IDE or MicroPython can be used. Thank you, students.